Here is the answer for day 1. Solve the equation algebraically and graphically. When doing it graphically, sketch the window from your calculator screen. So let's first solve this algebraically. We want to get the letter x alone. So do the distributor property to remove parentheses. This becomes 8x plus 16, and then minus 6x minus 3, and that's equal to 2x plus 10. On the left-hand side, we can combine like terms. 8x subtract 6x is 2x. And a positive 16 and a minus 3 makes positive 13. And that's equal to 2x plus 10. At this point, you might notice that there's going to be no solution because both sides have a 2x and the constant terms are different. If you don't yet notice there will be no solution, we can continue with the solution process. Next, we might subtract 2x from both sides. I'm writing a little s here to communicate to you that I'm going to subtract 2x from both sides. This makes 13 is equal to 10. The variable x is now gone, and we end up getting a false statement. 13 does not equal to 10. What that means is there is no value that you can find that could replace x in the original equation and ever make the left side equal to the right side. So the answer is no solution. Depending on your Algebra 2 teacher, you may have learned a symbol that represents having no solution. It's called the empty set symbol. It looks like this. We're also asked to show graphically that there's no solution. To do this, you use your calculator. So let me drag my calculator onto the screen. Push the y equals button, and for y1, type in the left-hand side of the equation. You want to type in the left-hand side of the original equation, not something that you figured out later on as you were doing algebra steps. Because what if you made some mistake as you were doing those algebra steps? Then you're just going to repeat that mistake on your calculator. So always go back to the original form when you're using your graphing calculator. For y2, put in the right-hand side. Now think about what an equation is. It's a statement that this expression is equal to this expression. So we want to know, when does y1 equal to y2? Once you've inputted these, press graph. Now, if you don't have the standard window showing that counts out to 10 in all directions, you can push zoom, and then choice 6 is zoom standard. Here's the first line, and now here's the second line. What do you notice about these? They're parallel, right? They never cross each other. There is no x value for which the one line ever intersects the other line. So we just need to show this picture on our paper. Again, I can't draw on the screen at the same time I have the calculator showing, so I'm going to have to slide that off as I'm drawing it on there. The y-axis runs straight down the middle of the rectangle. The x-axis straight across the middle. And since I did a zoom standard, there are 10 marks in all directions. The more of these that you draw, the better you'll get at fitting the marks into the space you have. Next, we had those two parallel lines. One of them appeared to touch at -5. 1, 2, 3, 4, 5. And it went uphill and appeared to touch the y-axis kind of right in that position there. Make sure you're drawing nice and straight. You don't want to bend that line. So you certainly could use a ruler or the edge of something that's straight to help you draw. The other one touched more in between this mark and this mark. And it was parallel to the first one. And I'll pull the calculator back on the screen so you can see how I did. So my drawing on paper is pretty close to matching what my calculator screen looks like.